Okay, this hearing will come to order. Without objection, the chair is authorized to declare recess at any time. Good afternoon. Welcome to this afternoon's hearing entitled Fossil Energy Research Enabling Our Clean Energy Future. Thank you to our distinguished panel of witnesses for joining us. We have discussed on this subcommittee previously that we all believe we must develop policies that both support American workers while also addressing climate change. I myself believe in a jobs-first environmental policy. That's why I'm excited to hold this hearing. We will focus on two draft bills that will do exactly that today, support critical research to mitigate the environmental impacts that come with the extraction and use of fossil fuels. Western Pennsylvania, where I'm from, plays a key role in all of this. We are a net exporter of energy, second largest producer of natural gas in the country. We have produced more coal than any state in the nation, and that has powered us through the Industrial Revolution, 2 world wars, produced most of the wealth that we enjoy in Western Pennsylvania to this day, to say nothing of employing thousands and thousands of men and women, supporting families, which also continues to this day. The energy industry remains a top employer in my district and region. People are working in these jobs and feeding their families tonight with this wealth, and we want to see it continue, but in a way that's environmentally responsible and does not deny what we all know is coming with climate change and the urgent need to emit less carbon and decarbonize our economy. Last month, we were able to have several members of the committee join us at the National Energy Technology Laboratories Pittsburgh site near my district, and we got to see firsthand some of the technologies and works that the folks at Nettle are doing. We are extremely proud of Nettle and happy that they are under new leadership, which is going to keep them going strong for a long time. It's the only national lab dedicated to fossil energy research. So we are going to be talking first about the Fossil Energy Research and Development Act of 2019, which will support their research activities there. Specifically, I'd like to highlight demonstration activities on carbon capture, and I know some of our folks today will be talking about the importance of that. We'll also be boosting research to talk about efficiency improvements, the prevention of methane leaks at every point in the natural gas infrastructure, increasing our investment in how to utilize carbon as well. We also are going to look beyond the power sector in today's hearing, which I think is vitally important. We tend to focus on the power grid, but of course we need to find ways to decarbonize the industrial and transportation sectors as well. So we'll also be looking at the Industrial Decarbonization Technology Development Act. Really rolls off the tongue, the IDTT. The bill would authorize an interagency research program led by DOE to develop technologies that will help us eliminate life cycle greenhouse gas emissions from both the industrial and transportation sectors. This can and should be a bipartisan issue, and I believe it will be based on conversations with my colleagues. Secretary Perry has said that you cannot have a real conversation about clean energy without talking about CCUS. Former Secretary Moniz has made very similar comments. The Department of Energy under the Obama administration released a white paper on this technology, saying that CCUS would be a key pathway to where we need to go on clean energy. And of course, as at least one of our witnesses has noted in their written testimony, the IEA has also noted that it could be 2 or 2.5 or 3 times more expensive to reach our climate goals by 2050 if we do not have carbon capture as part of the solution. So I think we're all on the same page there. We will do everything we can to push forward this knowledge and then have this also be a source of American jobs in the future, because we all believe that others in the world will be burning fossil fuels for a long time. We might as well have them buying carbon capture technology from the United States. So I thank our panel of witnesses again for being here today. Look forward to your input. And I would like to recognize my ranking member, Mr. Webber, for an opening statement if he is ready and his breath is caught.
Well, 1 out of 2 ain't bad, Chairman.
All right, go for it.
But I appreciate that. Thank you. I apologize for being late. My bicycle had a flat tire. But thank you, Chairman Lamb, for hosting this hearing. Today we will have the opportunity to hear about exciting new research and development in fossil energy. Last year in the United States, coal and natural gas comprised 64% of net electricity generation, with that number expected to only dip to 58% by 2040. The use of fossil fuels in the power sector, as you kind of alluded to, isn't going anywhere. We have incredible domestic fossil energy resources, and our economic stability depends on the power they produce. So it's no surprise that we have a robust industry here at home investing in the next development, that generation that you talked about, developing of technologies to produce and use American fossil fuels more efficiently, more safely, and at a lower cost for American consumers. Today's hearing is an opportunity for private sector organizations and DOE national labs to highlight their leading roles in fossil energy innovation. The scope and range of technologies being pursued is as vast as the untapped oil reserves in West Texas. We'll hear from expert witnesses about research in materials science that can prevent CO2 leaks in storage formations under high temperatures, high pressures, and chemical conditions. I'm also excited to hear about a joint project between the nuclear and fossil offices at DOE that uses supercritical carbon dioxide as the working fluid rather than steam to dramatically increase energy conversion efficiency at 1/10 the cost. While there are significant opportunities for worthy and exciting research in this field, it is our job here in Congress to focus federal agencies on the best use of federal funds. And that means directing the Department of Energy to focus on the basic and early stage research industry. Cannot do that on its own. They need to be collecting long-term data and maintaining expertise to provide industry with the tools necessary to achieve technology breakthroughs. Once that technology is developed, industry is best suited to take the lead, building on the DOE research to commercialize those very same technologies. We have seen incredible research and technology successes through collaborative public-private partnerships, and it's clear that this is the model that ensures federal research investments give the American people the most bang for their buck. One such example is the Air Products production facility in my home district in Port Arthur, Texas. This facility, which is one of only 2 industrial plants in the entire United States where carbon capture is currently in use at scale, captures over 1 million tons of carbon dioxide per year. Let me restate that. It captures over 1 million tons of carbon dioxide each year. This CO2 is then transported via pipeline for use in EOR, what we call enhanced oil recovery. With support from the Department of Energy, the technology developed and deployed at this facility is reducing the emissions from local refineries and producing affordable American fuel to power our economy at the same time. Today, DOE is making smart, targeted investments in early-stage research to advance the next generation of production and emissions control technologies through the DOE Fossil Energy and Research, or FER&D program. Funded at $740 million in FY 2019, the FER&D program conducts research that supports clean, affordable, and efficient use of domestic fossil energy resources. In order to ensure these limited research dollars are spent wisely, we must focus funding towards projects that are truly cutting edge, applying DOE's supercomputers, their light sources, and expertise towards developing next-generation materials while maximizing efficiencies. The complex fossil energy research challenges we face today will require an all-hands-on-deck approach. Academia, industry, and the DOE are the ideal partners to develop these solutions. I look forward to hearing about these very partnerships from our witnesses today. I'm particularly interested to hear from Dr. Erik Webb, who joins us from Sandia National Lab, welcome, Doctor, about how the DOE labs can take a leading role in this effort. I want to thank all the witnesses in advance for testifying today, and Mr. Chairman, you for holding this hearing, and I yield back.
Thank you. I now recognize Chairwoman Johnson for an opening statement.
Thank you very much, Mr. Chairman, and good afternoon to everyone. I do appreciate this hearing being held and on the Department of Energy's efforts to mitigate the environmental impacts of fossil fuels used in the power sector as well as in manufacturing processes. Historically, fossil fuels have served as the primary source of U.S. energy as they provide reliable power at low cost. My home state of Texas has played an important role in the fossil fuels industry as a leading producer of crude oil and natural gas in the United States. However, as our nation's priorities have evolved, we are now focused not only on using energy resources that provide low-cost, dispatchable energy, but also ensuring that these are clean sources of energy. That's why we must strengthen our investments in the Department of Energy's Office of Fossil Energy, which supports research to address the environmental impacts of fossil fuels. This includes the development of technologies such as carbon capture, carbon storage, and methane leak detection and mitigation. Last Congress, I was proud to support the Bipartisan Fossil Fuel Research and Development Act of 2018, which reauthorizes and expands these important research activities. I look forward to discussing our proposed updates to that legislation during today's hearing. While fossil fuels play an important role in power generation, they are also an important resource for the manufacturing sector, which is responsible for the third highest level of carbon emissions economy-wide. Manufacturers rely on the combustion of fossil fuels to provide high-temperature heat needed for a variety of processes, including the production of cement and glass. Technologies already being developed, like carbon capture, will play an important role in reducing industrial emissions, but we need to develop a variety of technologies that reflect the diversity of our nation's manufacturing sector, from traditional sectors like the automobile manufacturing to more innovative sectors like sustainable building materials. That is why I'm pleased that this hearing will also consider another proposed bill today, the Industrial Decarbonization Technology Development Act of 2019, which would authorize a cross-agency research initiative led by the Department of Energy to reduce emissions from long-distance transportation and manufacturing, investing in research to reduce emissions from these important economic sectors is essential to meeting our climate change mitigation goals. I'm looking forward to hearing from our distinguished group of witnesses today on the research investments we need to make the transition toward a clean energy economy. I thank you for being here today, and with that, I yield back.
Chair now recognizes Ranking Member Lucas for an opening statement.
Thank you, Chairman Lamb, for hosting this hearing, which is especially relevant to the natural gas industry in my own Oklahoma district. Fossil fuels provide over 80% of energy worldwide and remain the dominant source of energy here in the U.S. Petroleum, natural gas, and coal provided more than 80% of total U.S. energy consumption for the past 100 years, with energy reserves to power a nation for the next century. In order to responsibly use our vast energy resources, the next generation of fossil fuel technologies must be more efficient, cleaner, less expensive for American consumers. Fortunately, our country is uniquely positioned to prioritize the basic and early stage research that leads to groundbreaking technology. In the 3 years since the U.S. began exporting liquefied natural gas, we've become the world's third largest supplier. The U.S. is projected to double its export capacity by the end of 2020 and become the world's top exporter by 2025. This is an incredible achievement made possible by American science and technology. Federally funded research programs have a history of paving the way for industry innovation. DOE labs created the drill bit technology that led to hydraulic fracturing and horizontal drilling, revolutionizing the oil and gas sector. Basic research in geology at the Department of Energy Sandia National Lab led to the development of microsensor fracture mapping techniques for hydraulic fracking. And sensor technologies originally developed for aerospace applications at NASA and the Department of Defense have been used to improve safety in oil and gas development. In all these cases, industry partners adopted techniques developed in the laboratory for commercial use, maximizing energy production across the country. Today, DOE contributes to make key investments in early-stage fossil energy research, while the private sector takes the lead on efforts to deploy new technologies. innovators in our national labs are building on decades of groundbreaking successes in oil and gas production. I'm particularly interested to hear from Dr. Erik Webb on how Sandia National Lab is using monitoring systems and mathematical models to better understand the subsurface. His research will help fossil energy producers make more informed decisions before they drill a well, saving time, money, and reducing the environmental footprint along the way. We know that energy industry has the resources, the capital, and the capacity to successfully commercialize new technology. What they often don't have is the infrastructure to conduct early-stage research and maintain historical data. This is where DOE, national labs, and academia can help. At the National Energy Technologies Laboratory, the nation's leading fossil fuel lab, researchers are speeding up the process of high-performance computing using the laboratory's Joule 2.0 supercomputer, which recently received a $16.5 million upgrade that boosted this computing power by roughly 8 times. DOE researchers have helped industry optimize chemical reactor designs and measure and improve the efficiency of gas turbines. With DOE's research, industry can improve the next generation of power plants using computational models to save time and money in planning and producing power more efficiently with less impact on the environment. The department plays an important role in ensuring energy producers are utilizing the most efficient, safe, and clean technologies. We in Congress owe it to the American consumers to prioritize this important research and responsibly provide the needed energy for economic development while maintaining environmental stewardship. I want to thank you, Chairman Lamb, for holding this hearing, and I look forward to hearing from the witnesses today about the path forward for our next generation of fossil fuel technology. Yield back, Mr. Chairman.
Thank you. If there are members who wish to submit additional opening statements, your statements will be added to the record at this point. Now I'd like to introduce our witnesses. Ms. Shannon Angielski is a principal at Van Ness Feldman LLP, Washington, D.C.-based law firm that specializes in energy, environment, and national resource policy and law. She serves as executive director of the Carbon Utilization Research Council, which is a coalition of electric utilities that rely on coal and natural gas for electricity production, gas distributors, equipment manufacturers, national associations, state, university, and technology research organizations. CURC's stated mission is to advance technology solutions for the responsible use of our fossil energy resources in a balanced portfolio to support our nation's need for reliable and affordable energy. Mr. Elgie Holstein is the Senior Director for Strategic Planning at the Environmental Defense Fund in Washington, D.C. Prior to joining EDF in 2009, he was co-director of the DOE Presidential Transition Team and has held numerous senior positions in government, including the role of Associate Director for Natural Resources, Energy, and Science in the Office of Management and Budget, Special Assistant to the President for Economic Policy at the National Economic Council, and Chief of Staff for the U.S. Department of Energy under President Clinton. Mr. Jeff Bobeck is the Director of Energy Policy Engagement at the Center for Climate and Energy Solutions. Mr. Bobeck leads the work of C2ES in co-convening the National Carbon Capture Coalition, which includes executives from energy, industrial, and technology companies, labor unions, environmental and energy policy organizations. The coalition's stated mission is to simultaneously foster domestic energy production, support jobs, and reduce emissions. Spoken like a Western Pennsylvanian because I believe he is one. Prior to his current position, Mr. Bobeck served as Director of Communications and External Affairs for the U.S. Department of Energy under President George W. Bush, held senior positions with the American Automobile Manufacturers Association and the Global CCS Institute. Ms. Erin Burns is the Director of Policy at Carbon 180, a non-governmental organization focused on carbon removal, where she works with scientists, entrepreneurs, academics, and policymakers to create and inform federal policy on carbon capture, removal, and use. Prior to her current position, Ms. Burns served on the staff of Senator Manchin, where she handled energy, environmental, labor, and agricultural issues, and worked as a senior policy advisor for Third Way, a DC-based think tank, managing its carbon capture and removal, innovation, and other clean energy policy issue areas. And last but certainly not least, Dr. Erik Webb is the Senior Manager of the Geoscience Research and Applications Group at Sandia National Laboratories. Prior to his current position, Dr. Webb managed Sandia's Global Security Systems and Technologies Department, led the second line of defense program responsible for creating a nuclear detection network at international ports of entry in 50 countries. He also served on the staff of former Senator Domenici, focusing on energy and water policy issues, and as a fellow on the Senate Energy and Natural Resources Committee. Dr. Webb has a PhD in hydrology with emphasis in modeling and applied math from the University of Wisconsin. As our witnesses should know, you will each have 5 minutes for your spoken testimony. Your written testimony will be included in the record of this hearing, and when you've all completed your spoken testimony, we will begin with questions. Each member will have 5 minutes to question the panel. And we will start with Ms. Shannon Angielski, and I apologize if I pronounced that wrong. You can correct us so the rest of us don't do that.
No, I'm actually very impressed. Thank you. I think that's the first time that anybody has actually pronounced my last name the right way. So you must have come from Pennsylvania coal country, because that's where my name comes from. So let me just say thank you, Chairman Lamb, Ranking Member Weber, and to the members of the subcommittee for the invitation to testify and do so in support of the Fossil Energy Research and Development Act of 2019. As Chairman Lamb has already pointed out, the CURC is an industry coalition that's really focused on technology solutions for fossil energy utilization. What's important about our group is that members of CURC believe that American fossil fuels and ingenuity and technology innovation will satisfy our world's growing appetite for affordable energy, improve our energy security, increase exports, create high-paying jobs, and improve environmental quality. In order to meet these important objectives, members of CURC are at the forefront of their organizations and partnering with the Department of Energy to develop and commercialize technologies that will transform the way that we use our fossil fuels. Successfully achieving these objectives will require a strong public-private partnership with the federal government, providing strategic investments in the research, development, and demonstration that's needed, and that's why we are here to support the bill that is before this committee. Consumption of fossil fuels, as you pointed out, Mr. Chairman, it's on the rise both internationally as well as domestically, but I think the international aspect of this is really important to focus on. It's because it's due to the role that fossil fuels play in providing affordable, accessible, and reliable energy. According to the International Energy Agency and the United Nations Intergovernmental Panel on Climate Change, carbon capture, utilization, and storage, or CCUS as we call it, it will be a critical component of the portfolio of energy technologies needed to reduce carbon dioxide emissions worldwide. And the good news is that the U.S. has been a leader in the development of this technology with the support of the Department of Energy's world-class carbon capture and storage programs. By way of example, DOE supported the nation's first commercial-scale carbon capture demonstration project that is successfully operating on a coal-fired power plant in Texas. That's the Petronova project. And as the U.S. continues to invest in these types of projects and in the research that's needed, will benefit not only from cleaner power, but also from new markets for U.S. technologies, both domestically and abroad. I want to point out that Congress actually made a critical step last year in catalyzing a CCUS industry in the U.S. through the enactment of the Future Act. And this would extend and expand the Section 45Q carbon sequestration tax credits. And they're already incentivizing CCUS projects across several industries. However, today's CCUS technology is still at the earliest stages of deployment and thus relatively expensive to implement in some industries like the power sector. And that's why improved carbon capture technologies will be needed to help reduce those costs when implemented in commercial practice. I like to think of it as like the wind and solar industry about 15 years ago, actually. A combination of federal incentives, such as those tax credits, when combined with federal funding for research and demonstration, that's what's going to be needed to improve the technology so the cost of CCUS and carbon capture can be reduced and replicated in commercial practice. That's, again, why the draft bill that's the subject of today's hearing is really important to achieve that objective. Members of our organization and the Electric Power Research Institute are constantly evaluating technology development needs that reflect the changing markets and policies that impact fossil fuel use in the power sector. And about every 3 years, those technology assessments are communicated through the publication of something we call an Advanced Fossil Energy Technology Roadmap, which we published the most recent version of last summer. And this roadmap identifies pathways to accelerate the development of transformational coal and natural gas generating options that include carbon capture. And the roadmap identifies several transformational technologies that are also identified in the draft bill that can be available in the next 10 to 15 years, and that can also provide dispatchable, low-carbon power that's needed to support the growth of renewables on the grid. These include novel fossil power cycles, such as those that I believe Dr. Webb will refer to later, through supercritical CO2 cycles. And they also include processes or other technologies that are designed to facilitate the capture of carbon at lower energy penalty and at cost than conventional methods that we have available to us today. These processes are inherently more efficient, resulting in fewer emissions, and require less fossil fuel to be used to produce electricity. There's also specific research identified in the roadmap that is necessary to support these new cycles, including advancements in turbine technologies, high-temperature materials that are necessary to achieve those efficiencies. And their roadmap also outlines advances in carbon capture technologies that are designed to lower costs, and the development and testing of these technologies at test centers, such as the Wyoming Integrated Test Center and the National Carbon Capture Center in Alabama. And again, all of these elements of our roadmap recommendations are embodied in the draft legislation. It's important to recognize that some of these technologies are ready for testing today at some scale or even at some commercial demonstration scale projects. And that's why it's critical that federal policy support not only research and development, but also the piloting and demonstrating of these innovative first-of-a-kind technologies, without which they would not likely succeed in the commercial markets. And this means annual federal budgets should increase in the next several years to support the scale-up of these efforts as outlined in the draft bill. It's also important to note that Congress ensured that new technologies that receive federal funding through the research program and are demonstrated at facilities such as Petronova are not considered as a basis for regulating a federally mandated emissions standard. Kirk very much supports the intent of Congress through the proviso included in the Energy Policy Act of 2005, which was enacted to alleviate private sector risk with implementation of new early-stage technologies that are not yet economic or commercial. Kirk urges Congress to maintain this proviso by adding it into the Fossil Energy Research and Development Act of 2019. I want to conclude by sharing some of the analysis that's been conducted by the CURC in ClearPath with modeling provided by NERA Economic Consulting and Advanced Resources International that shows that there are significant economic benefits to the U.S. if the technology development outlined in the roadmap is undertaken under a wide range of scenarios. Our analysis projects that up to 87 gigawatts of market-driven carbon capture deployment paired with enhanced oil recovery by 2040 could result in significant increase in domestic oil production, lower cost and lower cost retail electricity rates, all of which contribute to substantial increases in annual GDP, as well as over 800,000 new jobs that are created by 2040. These macroeconomic benefits are described in more detail in my written testimony. Let me just close by saying we are pleased to testify and happy to answer questions.
Thank you very much. Mr. Holstein.
Thank you, Mr. Chairman. The clean energy revolution is indeed underway. It is rapidly evolving into a global competition for market share in a world that is coming to understand how little time remains to avoid the disastrous impacts from climate change. As long as fossil fuels remain a part of our energy profile, we will need strategies to improve their environmental performance. The pace of global climate change is simply too fast, and the consequences of inaction too dire to do otherwise. To fight climate change, American leadership is desperately needed at home and internationally. It is crucial for us to remember, however, that even as we invest in ways to reduce the environmental impacts of fossil fuels and develop and deploy non-carbon alternatives, we still need an overarching economic policy framework. That framework should provide enforceable, declining, and economy-wide limits on carbon emissions, all on a timetable that avoids the worst tipping points associated with unconstrained and rising greenhouse gas concentrations. That means achieving net zero global greenhouse gas emissions by 2050. While we have not yet developed the bipartisan consensus needed to enact a carbon price and limit, an aggressive program to drive clean energy and climate innovation is within reach, and it's needed right now. Such an innovation portfolio will help build political confidence by accelerating the decline in the cost of emissions reductions. America has the intellectual capital, the research infrastructure, the workforce, and the manufacturing prowess to solve our technology and climate challenges. And we do need to do it all. In the context of today's hearing and the draft bills you are considering, that means mounting ambitious research, development, demonstration, and commercialization efforts. To be sure, there are some efforts and technology directions mentioned in the bills that may not prove out. That is, they may not reach the goals of cost-effective decarbonization and marketable, viable technology applications. The point is to find out. The point is to find out. The Draft Fossil Energy R&D Act of 2019 wisely emphasizes the need for environmental integrity safeguards as part of any plan to develop and commercialize carbon management technologies. Such measures are needed to protect against haphazard and ineffective containment of CO2. We strongly endorse such measures as a key element of any carbon reduction policy or program. The draft Fossil Energy R&D bill also instructs DOE to undertake a research program to identify the best methods and to assess the state of technology for preventing and detecting methane emissions from the nation's extensive natural gas infrastructure. Now, I think many members of this committee have heard me say in previous testimony that natural gas, as we know, is mostly methane, and when it leaks or is vented into the atmosphere, it is more than 80 times as potent as CO2 over the first 20 years following its release in terms of the damage it does to the climate. In fact, methane is responsible for about 25% of the global warming we're experiencing today. We welcome the methane provisions in the draft bill. The Industrial Decarbonization Technology Development Act takes another aspect of controlling greenhouse gas emissions. It tackles another aspect, sorry. The power sector has seen many innovations that hold the promise of decarbonizing and building resilience in our electricity sector. But other sectors, including buildings, process industries, shipping, aviation, and manufacturing, have not seen the same level of technology, innovation, and adoption. That's why the IDTA offers a promising new focus on opportunities to drive industrial decarbonization. Of particular value is the bill's creation of 2 new entities designed to leverage those capabilities. First, it creates an advisory committee to bring to the department the best of government and private sector expertise in developing needed new technologies. Second, it helps the department overcome an area of long-standing weakness, translating technology development into commercial deployment. The clearinghouse function for best practices and technology should be seen not only as a way to accelerate emissions reductions, but also as an ingredient of national industrial competitiveness. And I think the members of this committee have seen how ARPA-E has done precisely that, taken technologies, helped to commercialize them, and get these industries moving forward so that America can have a competitive edge in this worldwide market. Taken together, these 2 draft bills represent a strong step in the direction of answering the key question about decarbonization. What works? And then getting solutions into the market. Thank you for the opportunity to testify today, and I look forward to answering any questions you may have.
Thank you, Mr. Bobeck.
I'm here representing the Center for Climate and Energy Solutions, or C2ES. We're an independent, nonpartisan organization with the mission of advancing real-world solutions on climate-related policy. We convene the Business Environmental Leadership Council, a group of 34 industry-leading companies. We partner with the U.S. Conference of Mayors, and relevant to today's topics, we co-convene the Carbon Capture Coalition, which has grown to more than 60 participants. C2ES considers carbon capture to be an essential component of a comprehensive response to climate change for 2 reasons. Despite the growth in renewables, we expect that some level of dispatchable, emissions-abated fossil power generation will be needed for decades to come. Mr. Webber mentioned 64%. Well, we're not going to turn that off by 2030. Second, the manufacture of products like steel, cement, and methanol produce greenhouse gas emissions as part of their basic processes. Carbon capture provides promising pathways to address both issues. The International Energy Agency repeatedly has concluded that approximately 12 to 15% of greenhouse gas emissions must come from carbon capture by 2050 if the 2-degree warming scenario is to be met. Moreover, IEA found that removing carbon capture from the emissions reduction toolbox would more than double the cost of keeping warming below 2 degrees. In the United States, the ongoing improvements in efficiency and cost of carbon capture owe much to the work of DOE's Fossil Energy R&D program and the work conducted by the National Energy Technology Laboratory, or NETL. Mr. Chairman, as you mentioned, I grew up in Pennsylvania's present-day 17th District, and I remember well our school field trip to what was then called the U.S. Experimental Mine. That facility became a national laboratory in 1999, and now, drawing on more than a century of history, NETL is the home of some of the most forward-looking energy research anywhere in the world. However, the program still operates under its 2005 authorization. Thus, many of its current research objectives, such as carbon utilization and direct air capture, were not envisioned by Congress at that time. The Fossil Energy Research and Development Act brings the program's statutory direction into the modern era, providing updated program guidance while allowing for flexibility as priorities change and technologies develop. It would establish regional centers to address region-specific capture, storage, and utilization needs. And it would provide higher funding authorization levels, which a wide variety of stakeholders, including industry, labor, and NGOs, would support. One area of research targeted by the bill I mentioned is carbon utilization, which C2AS believes holds great promise as a pathway for decarbonization, especially for industry. We will soon publish a new report on the subject detailing how utilization can be especially effective in addressing harder to decarbonize industrial sectors. The legislation before the committee today could help to accelerate carbon utilization's development and deployment. The second bill before the committee today, the Industrial Decarbonization Technology Development Act, would elevate the issue of industrial emissions to provide better cross-agency coordination of policy. Because industrial challenges for steelmaking in Pennsylvania are different from those for chemical processing in Texas, the bill would also seek better intergovernmental cooperation and would require development of a national roadmap for decarbonization of difficult-to-decarbonize industries. Allow me to close by saying a word about innovation. Innovation is not an end in itself, but rather a means to deploying a more effective and economical greenhouse gas reduction. The seeds planted by federally supported innovation will not bear fruit without the enactment of other complementary policies, without commensurate action at the local and state levels, and certainly not without strong commitment by the private sector to shoulder some of the risk. And we're behind. While nearly 40 million metric tons of carbon dioxide are currently stored or utilized annually around the world, the amount of carbon dioxide captured needs to grow by a factor of 100 by 2040 if carbon capture's necessary contribution to greenhouse gas reduction is to keep pace. No proposed single policy reform offers a silver bullet, but rather a portfolio of policies is needed to address technology development, financing, and market preferences. But one thing at a time. We commend the committee for proactively proposing thoughtful climate policies within its jurisdiction, and we look forward to working with you going forward. Thank you for your attention.
Thank you. Ms. Burns.
Thank you for the opportunity to testify today. I'm the Director of Policy at Carbon 180, which is an NGO focused on carbon capture, removal, and use with the goal of building an economy that sequesters more carbon dioxide than it emits. We choose to work on these issues for one reason: climate. We have a responsibility to take immediate and ambitious steps to avoid the worst impacts of climate change, and carbon removal alongside renewables, energy efficiency, and other emissions reduction efforts can play an integral role in eliminating global emissions. At the same time, we also have an opportunity to turn these carbon emissions into an asset, spurring American innovation and growth. We are supportive of the Fossil Energy Research and Development Act, as well as the Industrial Decarbonization Technology Development Act. My testimony will focus primarily on the first bill, which we support for three major reasons. First, this bill establishes the first ever dedicated carbon removal program at the Department of Energy. That term, carbon removal, refers to a broad set of technologies and practices that remove carbon dioxide from the ambient air all around us, and includes a technology called direct air capture. While direct air capture is a relatively new technology, there are nearly a dozen small-scale plants deployed today, with plans recently announced to build a plant that would remove 500,000 tons of carbon dioxide a year. To bring this technology to scale in time to meet climate goals and to maintain American leadership on innovation, it's time for the federal government to significantly increase support for carbon removal. Luckily, we know how best to do that. Towards the end of last year, the National Academies of Sciences released a report that detailed how the federal government can effectively move carbon removal forward. One of their most important recommendations was to implement an ambitious federal research, development, demonstration, and deployment program for direct air capture and other carbon removal approaches. To date, the Department of Energy has spent around $11 million ever on direct air capture, far below the tens and hundreds of millions of dollars of annual funding recommended in this NAS report. This legislation would scale up those efforts and get us far closer to the levels recommended. The Office of Fossil Energy has a long history of work on carbon capture technologies, and that expertise is well suited to tackling the challenges around other technologies like direct air capture. The second reason we support this bill is because it expands the carbon capture program to include natural gas and industrial applications. With the rapid growth of natural gas in the U.S., it is essential that the Office of Fossil Energy expand its historical focus beyond carbon capture applications for coal power plants to also include work on natural gas plants. Carbon capture is also essential to reducing emissions in the industrial sector, which represent around 1/5 of total U.S. emissions. We need to begin decarbonizing the production of steel, cement, and other industrial processes today. Efficiency, certain renewables applications, and advanced nuclear can all play a role. However, carbon capture will continue to be an important part of decarbonizing this sector. The provisions in this bill to incorporate work on carbon capture for natural gas and industrial plants reflect the reality of our changing electricity generation mix and are key to helping us meet climate goals. We are also very supportive of the Industrial Decarbonization Technology Development Act. It is essential that the U.S. work on a broad set of technologies, including but not limited to carbon capture, to rapidly reduce and eliminate industrial emissions. This bill is an enormously important step towards that goal. The third and final reason we support the Fossil Energy Research and Development Act is because it builds on the Office of Fossil Energy's great work on carbon utilization. Taking carbon dioxide from smokestacks or the ambient air and turning it into commercial products, such as plastics, fuels, or building materials, is what we call carbon tech, and it offers a promising near-term opportunity to begin commercializing the technologies needed for an economy where we remove more carbon than we emit. There are dozens of these carbon tech companies and startups in the U.S. today, and the U.S. is home to more of these projects than any other country in the world. We have an opportunity to build a significant domestic carbon tech industry. In fact, according to our analysis, there is a $1 trillion total available market for these products in the U.S. alone, and a nearly $6 trillion total available market globally. To date, the Office of Fossil Energy has spent only about $10 to $12 million annually on carbon tech research and demonstration funding. They've done some really great work, but they can do more and better work. This bill would nearly triple our current annual investment in these technologies and put the U.S. in a much stronger position to fully take advantage of this enormous economic opportunity. Carbon capture and removal are key to addressing climate change and can help drive economic growth. And federal policy action today can help unlock both opportunities. As Congress considers climate policies like this bill, we recommend looking to examples like the Carbon Capture Coalition and similar efforts where a broad set of participants, including environmental organizations, labor unions, startups, large companies, and others, have helped drive policy development and advocacy. Engagement with labor unions in particular, who have been foundational for carbon capture work historically, is key to unlocking the full economic potential of carbon capture removal and use. Thank you again for the opportunity to be here today. Carbon 180 strongly supports the Fossil Energy Research and Development Act and the Industrial Decarbonization Technology Development Act, and we are grateful for the hard work of the committee staff and others who have put these bills together, and I look forward to your questions. Thank you.
Thank you. And Dr. Webb.
Chairman Lamb, Ranking Member Weber, and distinguished members of the committee, I want to thank you for the opportunity to testify today regarding the importance of fossil energy research. I'd like to make 4 points. First, subsurface science is extremely complex and requires a spectrum of research activities that are applied from 10 kilometers below to the surface of the Earth and over 12 orders of magnitude in scale. They address the interplay of mechanical, thermal, chemical, biological, and hydrological behavior. Our most challenging problem is getting accurate in situ data that represents the heterogeneity in these deep, high-temperature, and high-pressure environments. Thus, basic material science and microelectronics research are essential to build new sensing systems to withstand these subsurface conditions. Sandia is working to integrate this basic science with geomechanical testing, modeling, drilling technology, data tools, and high-performance computing to build a next generation of real-time sensing decision approaches and tools to address this complexity. Second, subsurface research that is applicable to oil and gas production is equally valuable to enhanced geothermal production, understanding and implementing carbon sequestration, nuclear waste disposal, environmental restoration, basic research in geosciences, water resources management, and multiple national security needs. Historically, we can see this in the development and application of the polycrystalline diamond compacts that are embedded in drill bits, which were successful due to DOE's investment and are now used for the vast majority of oil and gas wells. They are also essential for enhanced geothermal energy production and carbon sequestration, accessing deep crustal basic science research and national security applications. A more recent example is the EGS CoLab project, funded by DOE's Geothermal Technologies Office, that involves 9 national labs and numerous academic and industry partners. This project is studying the interplay of stress, seismicity, and permeability. This understanding is also essential for preventing induced seismicity and accurate global nuclear test detection programs. Additionally, this type of research builds knowledge and tools and human competence in preparation for national emergencies, such as the Deepwater Horizon, the Aliso Canyon methane leak disaster, and the emerging challenge of wellbore integrity. Utilizing research across these challenges is enhanced when the sponsoring organizations recognize and encourage cross-use of the science base. Third, the complexity of these Earth systems motivates cutting-edge research. The Earth is itself our largest and most complex data set. Efforts such as NASA's Earth Observing Data and Information Systems are rapidly digitizing the Earth. However, they estimate the volume of data in this one archive will increase to 247 petabytes by 2025. This is very big data and will truly tax our data analytic and artificial intelligence tools. One of Sandia's investments in this area is the development of a real-time subsurface event assessment and detection capability we call RESEED to enable a step change in real-time continuous monitoring, advanced analysis, and decision-based management of the subsurface. Fourth, the nation's benefits from utilizing the technical capabilities of the whole national laboratory system. The labs do not replace or compete with industry, but instead fill a role in early-stage research of high fiscal risk or integrating across multiple disciplines. The National Energy Technology Laboratory is the Department of Energy's lead for fossil energy research. However, investments by other DOE offices builds capability in each of the national laboratories that can benefit fossil energy missions. This works best when the Department of Energy encourages connection across the whole of the national laboratories, academia, and industry. Sandia National Laboratories experience bears out these 4 main points. Thank you for the opportunity to provide testimony on the importance of fossil energy research. I would like to express my gratitude to the team of colleagues at Sandia who helped prepare for this hearing. We are energized by the challenges that face our nation and are grateful for the attention your committee pays to them. Thank you for convening this hearing. I look forward to your questions.
Thank you. We will now begin our first round of questions, and I will recognize myself for 5 minutes. Ms. Burns, if I could start with you. You talked a little bit about the economic potential of carbon utilization and the growing market that we have. I believe, sort of implicated in your comments, we have an example of it already happening in my district with the cracker plant that the Shell Corporation is building, basically in order to create polyethylene out of the runoff from natural gas drilling. There was a note in the table in your testimony about polyethylene being an example of what you refer to as carbon tech. So could you maybe address that in a little bit more detail about the economic potential that you see and how it's currently connected to things that are implicated in this bill? You know, what are the investments that we are making that may be likely to build on the progress we're already seeing in that space?
Absolutely. We did a market sizing report that I mentioned that showed that there's a $1 trillion total available market in the U.S. for this carbon tech goods. And in particular, as you mentioned, we see opportunities in certain sectors. Building materials, chemicals and plastics, and fuels are, I think, three of really the biggest. There are also things like specialty materials. There's a startup near DC actually making carbon nanotubes out of captured carbon dioxide. And though this bill does, I think, a couple of really important things for the carbon tech industry. The first is it really ramps up the investments we make in these technologies. To date, we spend about $10 to $12 million a year. A lot of that's really focused on algae applications. That's really great. Big fans of algae. There's a lot more out there. And so scaling this up is going to allow us to support other applications of carbon dioxide and carbon tech. The other thing it does is to scale up deployment of carbon capture and direct air capture technologies where we're going to have more feedstocks of captured carbon dioxide. There are already, I think, 80 plus projects here in the U.S. We have more than any other country in the world. And if we invest in these companies today, many of which are small-scale startups, though there are some larger examples like what you talked about, as well as Lanzatech and other companies, that we have an ability to take advantage of that and reap those economic benefits here in the U.S.
Oh, I agree. Thank you. And we've already seen great success at Nettle with the development of new membranes, which is exactly the type of technology that if we develop here, we would be able to sell probably anywhere in the world. So that's been great work by them. This is a question for the group. It seems to me that a lot of the demonstration scale projects in the power sector that have been done in the past were done sort of before or during the early phases of the natural gas revolution, and many of them were focused on coal. Rightly, that made a lot of sense at the time, but we're in a new era that has happened very quickly. So if anyone is prepared to talk about the practicalities of a demonstration scale natural gas plant with carbon capture, how soon we can get there, how our legislation or future legislation that we might do would impact that or help us, that would be very helpful.
Start with this. One thing that I want to point out, at least about post-combustion carbon capture, is that it is has a lot of broad applications among a variety of industries. So in the power sector, it can have a broad application in both coal or natural gas applications. And then on the other industrial sectors that are covered in the other bill that you're looking at, it's really sort of the solvents that are inside the equipment that need some of these slight modifications that can be utilized among a variety of industry applications. So it's important to note that I think that the federal as well as the private sector investments that are going into these technologies, no matter what the fuel type is that they're being designed for, are going to have a lot of applicability to other sources of natural gas or other industrial flue gases. I think where we are right now is that we need to take that research and we need to start testing it in other industries or more broadly across these other fuel sources.
I agree with that, absolutely. I just think that when you look at the numbers, for example, of what it could do to the electricity costs coming out of a coal plant versus a natural gas plant, they might be very different. I think we would probably learn things along the way if we were able to demonstrate that. Last point I wanted to make before I ran out of time was, Mr. Holstein, you did talk a little bit about methane detection and the prevention of leakage. And I wanted to commend the Environmental Defense Fund, which did some great work in the Pittsburgh area on our residential gas delivery system and detecting leaks. I think CMU and Google were a partner and actually drove all around the city of Pittsburgh to do that. So can you describe, maybe in just slightly more detail, and then I'm out of time, the way that our efforts in this bill will help us do that on a wider scale throughout sort of the life cycle of natural gas as it comes out of the ground through the distribution network?
Absolutely, and the two questions you've asked are clearly linked, at least in my mind, and in that the best starting place is to stop the leaking we already are learning about. And the good news there is that the private sector has responded with the development of lots of new tools for advanced leak detection, tools that, in the words of one of the companies, are 1,000 times more sensitive in detecting methane leakage than they were just a short time ago. Those tools are being mounted on vehicles, as we did in Pittsburgh and 9 other American cities, and will be rolling out in other cities around the world soon. Or they can be in drones or light aircraft, other manned aircraft. So there are multiple opportunities to put in place the technologies that can, help decarbonize the oil and gas sector in significant ways using technologies that are here right away. And by the way, what do they cost? About a 40% reduction cut right off the top using current technologies would cost less than 1 penny per 1,000 cubic feet of gas produced annually. So these are definitely things that are moving into the marketplace. My description of the applicability of these bills to those challenges simply is that, as I said in my testimony, it's terribly important that as we move forward with any of the technology pathways that are discussed in the legislation, that we have environmental guardrails, if you will, around that work. So an example would be we have to monitor and keep track of what is potentially leaking into the atmosphere. If we sequester carbon, we need to be sure that it stays there, let's say in a geologic formation. And so these technologies begin to multiply in terms of their benefits as
Thank you. And I probably have to cut you off there to get to the other members.
Sure.
Thank you very much. I now recognize Mr. Weber for 5 minutes.
Well, Mr. Chairman, I would have yielded you another minute if you'd yield me 2. So thank you, Mr. Chairman, for that. This actually is for all the witnesses. We talk a lot about developing technologies to capture CO2 from existing power plants. But we also know that the economics for capturing CO2 won't work, and I can give you the ARA money spent on the Air Products CO2 capture sequestration storage unit in my facility in my district in Port Arthur and some of the others. It's got to be in the right place. It's got to be close to a pipeline. It's got to have somebody that can use it. And of course, the example we use most often is enhanced oil recovery. All of those factors have to fit. So I'm aware that not every region, Texas is very big on energy, not every region has those kinds of properties where all of this fits nicely together. So my question is, what about the rest of the country? Is carbon capture in the way we often think about it? Or is it a new way of producing power, like using supercritical CO2 instead of steam? How do we make sure we're developing these truly kinds of revolutionary technology for the future across the country? And I forgot how is it Angielski?
Angielski.
Angielski. I'll start with you.
Okay. Thank you. I think that it's important to point out that there are at least a number of storage reservoirs that we are blessed with geology in this country, and so those storage reservoirs are not just enhanced oil recovery reservoirs. And so I think that will help to expand our regional opportunities for actually citing some of these projects or the technologies. Even in the Midwest, I mean, in Ohio and those regions, there are regions where we have really good secure geologies that we can store CO2 for millennia, and we're in the DOE is actually working
For a millennia.
well, that's my word, but yes, for at least
A long time.
a very long time. And so And then, others on the panel can speak to, as Erin has already pointed out, onto some of the CO2 utilization pieces of this.
Well, if I may, so would you be in favor of building a pipeline system that actually helped us transport that across the country for use, taking methane and CO2 out of the air and actually sending it through pipelines to the various industrial areas where they could actually use it?
So there is analysis that is looking at building some of those pipelines, and some larger pipelines that they call trunk lines that could take the CO2 from those industrial sources and actually move it to those storage reservoirs, either through enhanced oil recovery or
Okay.
otherwise.
Let me go to you, Mr. Holstein.
That's a darn good question. A lot of the answer to the question about the pipeline, the need for a national pipeline network, will be driven by the demand for, in this case, CO2. I think it's more likely, as we sit here today, and others on the panel may disagree with this, but I think it's more likely that we're going to find other ways to use CO2 if we're able to.
So would you transport it by tank car or by 18-wheeler, put more
no,
trucks
well-
or vehicles on the highway?
First, I would say that the markets are likely to develop regionally. In other words, if these technologies are applicable nationwide, there's no reason why we couldn't develop regional and even local markets for that CO2 that is captured. And so we may not need a national network of pipelines.
But would you agree the economy of scale for an area that's unlike Texas, where we have a lot of refining on the Gulf Coast, for example, 65% of the nation's jet fuel is produced in my district. It's a little more difficult in some of the other states where you don't have that kind of industry to capture CO2, whether it's out of the air or whether it's from a power generating facility, which we have, which is in Pete Olson's district, and I've been there. It's a little more difficult for those more rural areas to really have a market for that. So how do you capture that CO2 and get it to market?
Well, I think under the scenario I was discussing, I'm not necessarily talking about concentrations of petrochemical production, but rather suppose you're capturing the CO2 from power generation, as you just mentioned.
Sure.
There's no reason why that couldn't be useful, let's say, in the Northeast or the Midwest.
But it's for enhanced oil recovery for
And
the
for
most
enhanced
part.
oil recovery is exactly what I meant when I talked
Right,
about
so if they don't have oil wells
regional
up there
uses.
like we do in Texas, there's not really much of a market, is there?
Potentially in Pennsylvania, if you're asking about enhanced oil recovery.
Right. Well, I'm out of time, so I apologize to the rest of you. So, Mr. Chairman, I'm going to yield back.
Thank you. Recognize Ms. Fletcher for 5 minutes.
Thank you very much, Chairman Lamb and Ranking Member Weber, who is my neighbor at home in Houston. So I have a similar interest in a lot of these issues. And of course, I represent Texas's 7th congressional district. I represent the energy corridor, and it is, of course, the heart of the energy renaissance that we've been experiencing over the last decade or so. And so a lot of these issues are really critical, and I think technology is a huge piece of our path forward, and carbon capture technology in particular. So we've already touched on a couple of things that I want to follow up on and give some of you a chance to expand some of your answers with the time constraints. But I want to start first with a question for Ms. Burns, because in your testimony you were talking about turning carbon capture into an asset, and I think it would be very helpful if you could just elaborate on that and also touch a little bit on the difference between or kind of describe the technologies associated with the direct air capture, which I think is very different from what we've seen in these pilot plants, one of which is in Mr. Weber's district, and of course my other neighbor, Mr. Olson, who has the Petronova plant in his district. If you could touch on those, I think that would be helpful.
Absolutely. So to your first question about what we can do with the carbon dioxide once it's captured, you had a question about enhanced oil recovery and where these might be located. That's obviously where we see a lot of CO2 utilization today. However, we think that there's a huge potential to create more markets for CO2 and other types of applications. Right now, we do see some applications for things like beverages and food, or some niche applications like greenhouses. But we think that being able to, you can take these and turn them into things like fuels. So I'll use an example. LanzaTech is a company that has a project here in the U.S. They actually recently they partnered with, I think it was it Virgin, to fly a plane from Florida to London on fuels made from captured carbon oxides. we have a huge opportunity there. And a lot of these fuels, compared with conventional gasoline, if you make them from, if you capture carbon dioxide with direct air capture, those fuels that you can create from that capture carbon dioxide can be as much as 90% less carbon intensive than traditionally produced gasoline. To your second question about technologies for direct air capture, there are a bunch of options. The one that we hear the most about is direct air capture. There are 3 leading companies right now, one of which is a US company, and they have about 11 projects between them. And what this technology does is, instead of carbon capture technology that's installed on a smokestack, so at a power or industrial facility, you're actually able to take it from the ambient air. So again, to your point, where you're going to see these, you don't run into the same kind of challenges around geology, pipelines, enhanced oil recovery. When you're thinking about direct air capture, you can actually site them in lots of different places. And the other thing I would say, the last thing I would say, is that there are 3 companies. We're really excited about the work they're doing. There was recently a project announced that will capture 500,000 tons a year. That's huge. That's a really big deal. But we want a really robust ecosystem of companies in this space. We want more than 3. We want more than 3 technologies. We want to help drive down the cost of innovation. And the provisions in this bill to create that carbon removal program will help get us there.
Thank you. And I just have a quick follow-up. You mentioned the 3 companies. So it seems like this is an opportunity for the United States to have a leading role. Who are the other companies, or where are they located, the companies that are working on this as well?
Sure. So Global Thermostat is a U.S. company, and they have a facility in Alabama, I believe. Then we've got Carbon Engineering, which is a Canadian company, and then Climeworks, which is a company in Switzerland.
Okay, terrific, thanks. And I also want to follow up, and maybe I can just put this out to the panel for anyone who wants to take this on. But as I think one of the comments that you made, Mr. Holstein, was about kind of the other ways we can use the carbon, and we heard a little bit from Ms. Burns about that. But I think one of the challenges that we've seen across the board is, for whatever these other uses are, how can we move this from sort of interesting ideas and technologies to something that is, how do we make it economic and something that is commercially viable, so that we can start having this direct air capture, or we can have increased CCUS activity, given where we are now? Like, how do we move that forward?
2 quick answers, and I'm sure other panelists would have ideas. One is, that's why we have provisions in these bills that emphasize commercialization. We've been too afraid of commercialization. When I say we, I don't just mean Congress, I mean the environmental community and others. We don't like the idea of choosing technology winners, but that's not what this is about. This is about identifying sectors in which we need to make a leap forward, technologically speaking, just as we did with the space program, just as we've done in health and medicine. And as I say in the very first paragraph of my testimony, in response to the fact that this is a competitive race, not just a race against time as far as climate change is concerned. So one part of the answer is we're going to focus more on commercialization and fund those activities. And number 2, it's been great to see how Congress has come around on a bipartisan basis to fund organizations like ARPA-E that know how to move things from the workbench, if you will, past the valley of death and into the marketplace.
Thank you very much. And I see I've gone over my time, so I will yield back. Thank you all.
Recognize Mr. Cloud for 5 minutes.
Thank you, Chairman. I think I'm the 3rd Texan in a row, so appreciate you, Chairman, on hosting this important topic. Ranking Member Webber, this is a very key topic, certainly with national security, economic implications. I come from Texas as well, and we have a very diverse energy portfolio with wind, energy, oil, LNG, all in our district. And so I really appreciate the fact that we can have, with some of the discussions that have gone on here, a real pragmatic, solution-oriented discussion in this committee. And so appreciate that, Chairman and Ranking Member. Dr. Webb, I was wondering if you could talk to us. We just mentioned commercialization. How does Sandia encourage private companies to take on the commercialization of basic research applications? Your written testimony talks about the bayonet reactor and other projects. Could you expand on that?
The basic approach to commercialization involves one of 2 processes. If we have identified something in the early research stage that's promising, we'll make an announcement, a public announcement, so there's fairness of opportunity to U.S. industries to come and join us in that research process. And so we would then share that intellectual property between the U.S. government and the industry, and they would, at the end of that research process, be experts in that technology. And that's an excellent sort of process we call a cooperative research and agreement process. Secondly, if we've made investments, whether it's through DOE funding or through our internal lab-directed research, and we have breakthroughs, we will go through a process of patenting that research, and then again, we make that available in a fairness of opportunity process. And there are a number of other tech transfer mechanisms that are used. Sometimes we will allow staff to go for a 2-year leave of absence to work for those companies to carry that research into application. And so it's really our objective to ensure it gets used. And we have multiple of those mechanisms to do that. So the examples in my testimony really are examples of individual technologies that have gone out, but embedded in there are these processes that allow us to do it.
Would you care to mention a couple of those projects that have been successful that you?
Well, certainly the one that I mentioned in my initial testimony of the PDC bits, we did not patent that, but that was done with industry, and now it's being used for 90% of the wells and holes drilled on the planet. That's an extremely obvious, successful example. The bayonet technology that you brought up that I also mentioned is one that converts methane to farm fertilizers and other kinds of precursor chemicals. That's been commercialized. It's been transferred to small industry. There are wellhead scale demonstration projects under our commercial process underway. And then we've got this Memzyne technology, which is another one of these CO2 capture technologies that's basically biomimetic. It's patterned after the wall of a cell in the human body, and that technology has been commercialized through a partnership with the University of New Mexico and is now getting put into application.
And could you speak to some of the work that the lab has done on carbon capture and underground reservoirs?
So we have really two focal areas. One is to understand what happens to CO2 when it is injected into the subsurface. It goes into pores, fractures and pores in the subsurface, but does it stay in a liquid form? Does it mineralize? Does it become permanent in that place? And a lot of that work was funded under the DOE Office of Science, a series of research projects, 9 years with the University of Texas. And that was very successful in producing a science base for what happens in the subsurface. We're also part of one of the field demonstration activities where we're doing a enhanced oil recovery demonstration project in the Farnsworth Formation in the Panhandle of Texas. And that's allowing us to monitor the front or the movement of the carbon dioxide into the subsurface using geophysics and other tools to watch that process and to understand where it goes. How long does it stay there, and is it captured?
I only have 10 seconds left, but let me just say, I appreciate the work on practical solutions for an American solution. I've thought that technology is more the answer than it is retreating to a pre-industrial age America. So appreciate the work that all of y'all are doing in this area. Thanks so much for being here.
Recognize Ms. Horn for 5 minutes.
Thank you very much, Mr. Chairman, and thank you for holding this hearing, Mr. Chairman and Ranking Member, and thank you to the witnesses for being here. I agree with many of my colleagues. This is a critical issue that we have to solve in a thoughtful, intentional manner. Coming from Oklahoma, it may sound a little bit like Texas. We, of course, have a strong presence of diverse energy sources, from hydrocarbon to natural gas, wind, and solar. And since 2005, we've seen in Oklahoma and other places reductions in greenhouse gas emissions, in part because of increased deployment of renewable energy sources, as well as less reliance on coal-fired electric generation, especially through the use of natural gas. And this, I'm going to open it up to the whole panel, is I'm curious for any of the witnesses what you see as the role of natural gas playing in this transition process to more renewable sources.
Thank you for that question. That's a great question. C2ES has convened an advisory committee of industry precisely because there's not a lot of talk about what the path forward for carbon capture and natural gas is. There's been such a great gain in terms of greenhouse gas reduction from fuel switching that some people want to rest and say, well, we're okay now. Well, eventually we will have to capture the emissions from natural gas. For a variety of reasons. One of those reasons is it is a world market. The world will demand low carbon fuel, low carbon power. So we've really been trying to focus on what are the answers for the path forward. One is obviously reduction in cost, and that's what this bill before us today is all about. You know, the carbon capture program is aimed at lowering costs across the board. The other is building out a network of pipelines that will reduce the cost of transportation. But you know, again, we expect this all to begin to intersect in around the 2030 range, but it needs help. There are a variety of policies that you all should be looking at that can help it. And I'll leave it there.
Thank you very much. This question is for Mr. Bobeck and Ms. Burns. As you know, and this is to follow on from the first part of the question, that over half of our electricity generation in this country still comes from coal and natural gas, and even as the percentage of electricity from fossil fuel generations continues to reduce, we still have work to do to manage this transition. So as we do that, not only thinking about the environmental costs, but also the economic costs and how we can incentivize this, I'm curious to hear your opinion about the realistic transition in technologies and the movement between these sources that it's going to take, and what innovative ways you might suggest that we look at as a Congress to help move this along.
Sure, I'm happy to make a couple comments, and then I'm sure Shannon has some that are even more insightful. So I'd say I think this bill is a really important first step. As you mentioned, a lot of the carbon capture research has been really coal-focused. As Jeff mentioned, this is operating off of an authorization from 2005. Our reality today is very different. Those kinds of the robust R&D programs that we're seeing here are really important. I think another provision that's really important in this bill, or something else that's really important in this bill that goes to both of your questions about changing electricity mixes, is that there are places in here where the Office of Fossil Energy also has to work with the Office of Energy Efficiency and Renewable Energy. And as we see more integration across different types of electricity generation, that type of collaboration across offices is really, really important. The last thing I'll say, and give Shannon time to talk, is that policies like 45Q, that was really important. I think, you know, we're huge supporters of that. There are other policies like that, market pull policies, that can help the deployment of carbon capture in addition to R&D.
Thank you. And I only have a few moments left, so if anybody has a quick comment.
I would just add that I think from a technology perspective, the need for flexible operations in the power sector is going to be increasingly more important with the growth of renewables, as you mentioned, on the grid. And by that I mean we need to have still dispatchable generation on the grid, but that can follow the load that is being provided by wind and solar. And so that is one of the critical areas of research that's identified, I think, in this draft bill that will be important for fossil fuel generation, which is still going to provide a significant amount of that electricity well into the 2040 timeframe. So,
Thank you very much, and my time has expired. I'd yield back. Thank you.
Thank you. Recognize Mr. Norman for 5 minutes.
Thank you, Mr. Chairman. I want to thank each of you for taking the time to come today. Mr. Bobeck, I think in your earlier testimony, you mentioned there's some industries like steel, cement, paper production that have no alternative to carbon dioxide emissions. With the demand for steel and materials, and I'm a general contractor, with steel and materials set to only increase, some companies like companies in our area have made it a goal to be carbon neutral by 2050. To what extent is the Office of Fossil Energy exploring the application of carbon capture to industrial sources such as steel?
They've done some great work in this area, and that's why we all, I think everyone at this table, is very bullish on the future of carbon utilization, especially for its application in those areas. One of the things we think about, we've talked about building out large pipeline networks, but something carbon utilization does is help you in geographic areas that are more difficult to decarbonize. For instance, if you've got a cement plant, you don't have to necessarily build a pipeline 200 miles away to store it. If you can build some sort of utilization plant nearby, you can utilize that CO2 right there, so it cuts the costs of the transportation, obviously, and creates something of value. So it's a very, very important thing. The FER&D program has led the way on many of these technologies, but it is very explicit in this bill, and we see that as something very important going forward.
Okay, in line with that, how should the Office of Fossil Energy prioritize decarbonizing the industrial sector emissions?
Well, we think it's critical. It's a little over 1/5 of all CO2 emissions in the U.S., and again, because there isn't a simple renewable solution, say, because these are intrinsic to the processes of making these products, it's very important to look at different ways of decarbonizing. For instance, pre-combustion decarbonization. We were talking about jet fuel before. It's very hard to decarbonize or to capture the carbon from jet fuel post-combustion. It's much easier to lower the carbon content at pre-combustion. So we would say it's a very important thing, and we commend the committee for actually having a bill that focuses on this.
Okay. And I guess I've got 2 minutes, but quickly, I guess for all of you, the Department of Energy's Advanced Manufacturing Office has been a leader in increasing industrial energy efficiency. However, has not paid much attention to more transformative zero emissions pathways. It's been recommended that the AMO, FE, and other relevant DOE offices develop technology roadmaps that could help achieve these pathways, with carbon capture being the main component. Do you agree with this strategy? Ms. Angie, we'll start with you.
So I honestly have not given that as much thought as you have. So I would say that there's always opportunities to leverage across the program offices within DOE and cross-fertilize their areas of expertise to get real and much better and more efficient results. So,
and we need your help on that, getting a roadmap on literally what to do, because you're flying in the dark unless you have specifics, and y'all have that.
I agree.
And I might add, Congressman, and the chairman mentioned I'm a former chief of staff at the Department of Energy, so I have enormous respect for the Fossil Energy Office and indeed for the national labs that are playing such a key role in all this. And I would simply say that one of the things about the draft legislation that's so impressive is that it does encourage this broad look, but it also brings forward, as I say in my testimony, the very best expertise from outside the department, for example, in the form of an advisory committee. The need for technology advice, I think, is terribly important. I think Congress needs it too, which is why I'll throw in my 2 cents and endorse the legislative appropriations bill that the House has moved forward that would reconstitute the Office of Technology Assessment, which 25 years ago was doing a fabulous job of advising the Congress on technology matters, including the kinds of questions you're just asking. OTA needs to be reconstituted, and I think Congress is right to do that.
Thank you. I'm out of time. I wish we could have gotten to the others. Thank you so much.
Thank you. Recognize Mr. McInerney for 5 minutes.
Well, I thank the chairman. I thank the witnesses this afternoon. Ms. Angielski, I thought I heard you say that the U.S. leads in carbon capture technology and storage technology. Is that right? So, what would be the economic benefits to the United States with that leadership by 2040?
So I think that there are a number of different ways that you could look at the economic benefits. One of the more immediate would be through carbon utilization, has been discussed by many of the panelists, whether that's through additional oil production by putting CO2 into enhanced oil recovery, whether it's through creating new carbon conversion and utilization markets. I think it's through the manufacture of equipment. It's through additional new jobs that will be created through a new industry that will hopefully emerge in the near future. So I think that there's a number of different ways. And then, of course, if we can manufacture equipment that can be sold overseas, in addition to selling more oil overseas, I mean, we can see some real improvements from just exports and GDP.
Thank you. Mr. Holstein, you said that significant safeguards are critical to CCUS. What might that look like? How would that be implemented? Safeguards.
Certainly. So you need to use monitoring technology, which is now pretty commonly available, to ensure that you're not experiencing the leak of CO2 into the atmosphere, which kind of would defeat the whole purpose of all your efforts to remove that from the atmosphere if it just sneaked its way right back in there. So detection technology, the chairman referenced earlier the project that EDF has had in 10 cities where it's a different kind of thing, but from a technology standpoint, this is becoming a very cost-effective industry in detecting with advanced leak detection technology, the escape, in that case, of methane, but CO2, same kind of thing. Be happy to provide to you, if you're interested in following up, examples of companies that are doing this kind of very sophisticated leak detection work now.
So that could be applied to CH4 fugitive emissions as well then?
Absolutely is being applied to fugitive emissions from the oil and gas sector right now. And we need more of it.
I should say so. Mr. Bobeck, I thought I heard you say the cost of carbon capture and sequestration would be greatly exceeded by the cost of not doing it. Was I correct in hearing you say something like that?
I don't think I put it exactly that way, but it depends on if you take all the societal costs into account.
So you agree that that's the case?
Well, you know, again, we're behind, and this is such an important technology if we hope to reach the 2-degree warming targets. And what I did address was if you take it out of the toolbox, it makes everything else more expensive.
Okay, that's another way of saying it. Thank you. Mr. Webb, I worked at Sandia National Labs in Albuquerque as a contractor for many years, so appreciate the great work that you guys do there.
Yes, sir.
Could you describe what the subsurface carbon storage looks like chemically? What happens when you put carbon in the deep subsurface?
So one of the things that happens is that it bonds with or mixes with water in the subsurface and or any other fluids, oil, gas, that may be in an enhanced oil recovery process. And then as it reaches certain pressures, it gets into a liquid form, the CO2 does. And this becomes a caustic material. It has a tendency to dissolve things that are in there in mineral form. And so it's a very complex chemistry. And as a result, you can have precipitation of minerals in various pores. That would potentially be a good situation because it creates something that's more permanent. Or you could have things that are areas of the formations that you're pushing into that effectively become blocked by those, and you can't access all the pores.
So is there a danger of contaminating groundwater then?
Well, carbon dioxide by itself would not contaminate groundwater per se, and all of the formations that we've looked at as prospective sequestration sites are much, much deeper than groundwater formations at this point. But in addition, in order for carbon sequestration to work, there has to be a cap rock. There has to be something that holds the carbon dioxide in place, and that cap rock would also be then the barrier between the lower sequestration and the surface water. That would be the groundwater systems.
If the chairman will indulge me, are there a lot of sites like that around the world, or is that a rare thing?
One of the first parts of this carbon sequestration program was that NETL did a national map of potential locations in the subsurface that would work for this particular activity, and there are a lot of potential sites.
Thank you, Mr. Chairman.
Thank you. Recognize Mr. Caston for 5 minutes.
Thank you, Mr. Chairman. Thank you to our panelists. So in order to get the CO2 down to where we are all safe as a species, I kind of divide all of our universe of things we have to do. We don't have a choice we have to do all three of these, but into 3 buckets. We got the first bucket of things where we will invest capital and then save money on energy. Renewables, efficiency, conservation, we will earn a return on that investment. May or not be a return we like, but we'll earn a return. The second bucket is stuff that we have to invest capital and we may or may not earn a return, which I'd broadly characterize as R&D, right? We're going to do our best, and hopefully if we succeed, we move some things into that first bucket. And then the third is that even if we do all of that and we stop emitting CO2 tomorrow, we've got to get the atmospheric CO2 down below 400 again, which means we're going to have to do a lot of airside separation in some fashion or another. And that's going to be capital intensive, and it's going to cost a lot of money to operate. And I take your point, the social cost of carbon is higher, so we have to do all 3, but that's the hardest bucket economically. For obvious reasons, let's focus on the 2 buckets in this panel, and I want to start with Mr. Holstein and Mr. Bobeck. It's always struck me that the hardest piece in the industrial space is that slate of industries that use fossil carbon as a reducing agent. Fertilizer production, cement, steel, silicon, we need those products to have the kind of lifestyle we want, but it's really hard to think of how to do that without coal and natural gas. As you look at those sectors, are we doing enough? Are there technologies you're particularly excited about? And if we can't get those sectors decarbonized, what residual of carbon emissions are we looking at that we just have to deal with continuing to emit that level to maintain the current lifestyle that we have?
Well, I'm going to bring up something that is not within the jurisdiction of this committee, and that's a carbon pricing system, which would spread the cost of carbon across the economy and help us decarbonize as a foundation building up. So that's the one thing I'd like to bring in.
That actually was exactly what I was going to say. It's the 4th bucket. And the reason why in my testimony I said we needed this overall economic framework is what I called it. But basically it's limits on carbon emissions that ratchet down over time and putting a price on carbon. And the reason you need that is because that's the only way you can be sure that all of this R&D work and all of this deployment that we are seeing in non-carbon energy sources, for example, are actually going to get us where we need to get below that 400.
So if I could, you don't need to persuade me of the need to price carbon. That's fine. I do want to stay within the jurisdiction of the committee, though, because there are practical thermodynamic constraints that are jurisdictional to this committee. There are market structuring constraints that are subject to other committees. And in those fields, like steel making, like silicon, how do you make a solar panel without silicon? How do you convert quartz into silicon without coal? I don't know how to do that. And how do you make fertilizer without natural gas? I don't know how to do that. And my question is, are we doing enough in those fields from an R&D perspective? And do you guys see a path where we will have those sorts of tools available, or do we have to assume that those sectors are going to be undecarbonizable?
I think it's neither of those. I think once you send a strong signal from Congress, from the states, Governor Cuomo just yesterday with his announcement for a climate plan, you send a signal about where the country is headed and the need to develop these technologies and pass bills like the ones we're discussing today that push toward commercialization. You start creating demand for and strong signals to encourage the private sector to make the innovations to either change those products or perform the same functions of those products using different approaches.
Okay, well, with the minute or so I've got left, and I want to believe you're right. I get nervous when it's the innovation will save us when I don't see the technology path. So if I could move to Ms. Angielski, I'm sure I'm saying your name wrong, I apologize, and Dr. Webb. Same question on the airside capture. These technologies are thermodynamically going to be very large and going to cost money to operate. As you look at the technologies that are out there, if you've got to start picking some, are there some that are inherently going to be cheaper? And I'm staying on the economics for environmental reasons. The lower the cost it takes to lower the carbon, the more carbon we can reduce with finite resources. So I'm not for a second saying that economics trumps, but I want to understand in your expertise, as we look at ways to pull CO2 out of the atmosphere, are there technologies you're really excited about?
A short answer from me, I think that the only way we'll do this efficiently is to follow biomimetic, biological processes. And so that's the source of research that we should be looking at.
I would actually defer to Erin Burns on this question, if I might do that, because we focus on industrial flue gases and the capture from that source.
Yeah, so we think the economics are really important too. I would say a recent Rhodium report had shown that without additional innovation, just by learning by doing, with the current technologies from the 3 leading companies we have out there today, we might get as low as $46 per ton. That's not zero, that's not positive, that's still a really long way.
It's below the social cost.
Exactly. And I think when we're talking about that, when we're talking about the scale of deployment for direct air capture and the timeline, we're looking at really large scale in the 2030 and 2050 timeline. That's also why we're really excited about this bill. There is a lot of innovation to be done. Right now, the federal government has spent a total of $11 million ever on direct air capture. That is a drop in the bucket. We need a lot more. And the fact that this bill would establish the first ever carbon removal program is really exciting. It's also really well funded. I would also say to your earlier question really quickly, I think there's a lot of technology we're excited about, and I think part of the reason we're so excited about the industrial decarbonization bill in conjunction with a fossil energy bill is that it does open up, we haven't done a lot of industrial R&D. It hasn't been on carbon capture. There's been less at DOE, and this bill would look at things like innovative renewables applications that could replace some of the heat from fossil fuel. Carbon capture is actually cheaper on some industrial applications. We see a lot of small-scale deployment in the U.S. on carbon capture, and a lot of that's in the industrial sector, so when you're talking about fertilizers. I would also say that there are new and innovative ways to make some of these materials. Some of that's using captured carbon dioxide, but there are other pathways that aren't just the Portland cement pathway that could help reduce those emissions further. So that's all to say, there's a lot of really cool stuff happening, but we need more R&D, and that's why we're really excited about these bills.
Thank you all. I'm drastically over my time, but I thank the chairman for allowing me to extend.
And last but certainly not least, we recognize Ms. Stevens for 5 minutes.
Thank you, Mr. Chairman, and great to be with you all here. It was actually great that my colleague from Illinois was going over because it was picking up with some of the things that I wanted to talk about. And actually, let it be known for the record, I say this all the time about the Science Committee and our hearings. It's the Midwesterners who rule the roost here. So thank you to our chairman, from Michigan, and, delighted to be talking about this. But just kind of picking up where we left off with Mr. Kasten. Okay, carbon capture. You're all making a nice case for it. We're glad to hear about the legislation and what it means to you. But let's drill down a little bit further. We've made this, Ms. Burns, you were talking about $11 million that we've invested, a drop in the bucket. How far behind are we? What happens in the aftermath with the carbon capture? Are we burying it? Is it producing another economic opportunity or technological opportunity for us?
Absolutely. So the $11 million is specific to direct air capture. We've actually spent, I don't know the full number, but right now we spend about $100 million a year on our carbon capture program. Still, we need more. And again, this bill pushes us in the right direction. Once you capture that carbon dioxide, there are a couple different things you can do with it. We think that if you deploy carbon capture and carbon removal at the scale that you see in climate models, the vast majority of that carbon dioxide you're going to need to store underground. And it's like Dr. Webb has said, we are blessed with a ton of great geology for this. We know how to do it. Also, carbon storage program at the Department of Energy and the Office of Fossil Energy has done some great work with this. The other thing that you can do, and something we're really excited about, is you can convert it into commercial products. And this is a new industry. We've got some companies who are at the forefront, but we've got dozens of projects in the U.S. And I think right now we have an opportunity. There are more projects in the U.S. than any other country. I think with more R&D funding, more federal support in the form of provisions like 45Q, that we can maintain American leadership on this. We can really help develop this industry, and we can take advantage of a $1 trillion total available market.
Yeah, that's what we talk about a lot here in terms of the Science Committee and our agenda, which is catalyzing new channels for economic opportunity, as well as addressing some of the larger challenges that stand before our environment. And picking up also with Caston's comments about the fertilizer and some of the industries at scale, we obviously have a reliance, and in some ways a reliance that I'm proud of as a representative from southeastern Michigan on traditional manufacturing materials like steel and concrete and aluminum. And in terms of how we think about the investments needed to decarbonize the production of these materials, some of which rely on decades-old processes without putting these companies out of business. What's at play here? How do we do that? Is it a grants program? Is it leveraging something through DOE? Is it something we can tie in to the legislation? Anything that any of you guys had thought about that you can weigh in and hear in terms of that?
I would say, I think there's been a lot of talk about, we use the term research and development, but we think that those questions around just demonstration and deployment, later stage work with the private sector is really, really important. The Office of Fossil Energy has done a lot of that, but there are companies like ArcelorMittal, who is a steel company in the Carbon Capture Coalition. They are looking at projects for industrial carbon capture. The Steelworkers Union, all of these groups have been really involved. And I think if we look at ways where we can not just do that kind of lab scale R&D, which is really important, but later stage partnerships where we have cost shares between private companies and the Department of Energy, we've seen that catalyze technology deployment. And I think that's a really important piece of this, and we're glad to see it reflected in the legislation.
Yeah. Mr. Bobeck, did you want to chime in here at all on any of this?
One thing I'd like to say about that particular issue is something in this bill we like very much is the focus on large-scale pilots. We've all heard of the Valley of Death, and so I think I said somewhere in my testimony that there's nothing worse than a project that doesn't get built after all this innovation and research goes into it. So it is very important in this bill, we believe, that there is interest in taking this through at least close to the commercialization stage.
Yeah, no, that's great. And it's obviously also something, as we think about the mark that we want to make and as we're legislating, it's the built environment, right? So we're navigating within that. I mean, I just led a big initiative on clean tech, tax credits and getting that back rolling and what that means. And it's not that we're leaving industry. So Holstein, did you want to chime in? You just raised, and by the way, great background. We're delighted you're here. But did you have something you wanted to add?
I think in the interest of time, I think Jeff said it beautifully. I would just add that Dr. Webb mentioned in the course of, I think, one of his answers, that the national laboratories, not just his, but most of them, if not all of them, have programs in which they generate patents, work with the private sector, and even let their own researchers and scientists take leaves of absence to help commercialize the technologies that in many cases they spend years developing. I also mentioned ARPA-E, the Loan Programs Office at DOE. All of these things are moving us more in the direction of the late stage commercialization that we need that we really need, and that other countries like China do just routinely, reflexively. We need to be less afraid of being accused of, industrial policy crazy people.
Yeah. Thank you for chiming in. Thank you, Mr. Chairman. I yield back.
I think at this point it would be crazy not to do what you're saying, you know? So lastly, Mr. Foster for 5 minutes.
Well, thank you, Mr. Chairman. And I guess as one of those members who did visit Nettle just a few weeks ago, it's just amazing. I worked for most of my career at a national laboratory, and yet there are these jewels scattered all around our country that, that certainly Congress is not as aware of as they should be. And they're doing all these great things. Just to understand the fundamental physics of combustion is a field which will have a huge benefit because, as I'm sure has been mentioned multiple times, we're not going to stop burning fossil fuels anytime soon. I'd also like to second the ranking member's endorsement of R&D into using supercritical CO2 as the working fluid for a high temperature, high Carnot efficiency method of generating electricity. And so one of the frontiers in fossil fuels is trying to deal with the high temperatures, which is, obviously hard on materials, but potentially very good for the efficiency of. And so are we looking down all of the relevant, caves of possible technology development along those lines, because it's one of the ways of making fossil fuel combustion, more efficient.
Let me take that question, please, Congressman Foster. So the material science element of this Brayton cycle supercritical CO2 energy conversion process is the focal point of a joint research program that's shared between the Nuclear Energy Office and the Fossil Energy Office, in particular focusing on materials. And these are both metals and the sort of gasket seals and other things that are needed in the system that are eaten away by CO2 at those pressures and temperatures. If it's effective, then it provides not only a more efficient energy conversion process, but it also potentially removes the water demand for cooling. And that allows us then to move energy generation to different places in the country. And I know that you've held a water energy hearing here recently, and that would also address some of the concerns that were brought up in that hearing.
Yeah.
I just wanted to add that DOE actually has a pretty robust high temperature and pressure materials program through the Office of Fossil Energy that they are working in a consortium with private sector and public sector interests. Through that consortium, they are about ready to undertake testing of components at these higher temperature and pressures. And so that way they can also move those materials into a phase where they can become standardized and we can actually start using them in these either new technologies or more commercial applications. And that program is ever evolving to look at some of these future applications of supercritical, when I say future, I mean more near-term future, but supercritical CO2 cycles, whether direct fired or indirect fired cycles that we see as really promising to achieve those efficiencies that you're talking about.
It's also an issue, I guess, right now in the horse race, but when you separate out the nitrogen to throw it away, either whether you burn the carbon and hydrogen in with a stream of pure oxygen or whether you try to deal with it later, which is looking like the low-cost solution to that. And are there solutions to the very high temperatures that you come to when you burn in pure oxygen?
So we don't want to pick winners and losers, but I will say from a promising perspective, as Jeff mentioned earlier, the pre-combustion aspect of these new power cycles is really very appealing because you aren't dealing with nitrogen in a post-combustion capture, more diverse, low concentration source of CO2. And that's really what the real difficulty is in carbon capture today. So if you have these new process cycles where the carbon dioxide is merely a byproduct of that cycle, or water along with it, you're producing this concentrated source of CO2 that you then can just do what you need to do with it. So from a cost perspective, that's clearly much more appealing.
Yeah, but then you have to find a way to generate the oxygen for cheap. And that's one of the challenges. Are there any prospective improvements in the efficiency of oxygen plants to do that, or is that pretty much immature technology?
I'm not in a position to answer that question. I'd have to do my own homework.
Okay.
I would just add that DOE and a lot of the industrial gas separation companies are very much invested in looking at improvements in those technologies. And there are some other novel approaches to it such as chemical looping, for example, a different form of oxygen that is concentrated that you could put into a combustion chamber. So there are some innovative things that are taking place to look at other ways of providing that oxygen.
That's
for
good.
combustion.
Yeah, so it's really wonderful. But you do actually have to, at some level, place bets and pick winners and losers. And it's one of the, it's difficult, and you don't want to have too heavy a hand. But both Congress and you have to choose the most promising technologies to put your money on. And it's a problem that none of us can hide from. And it's nice to see, really top-notch people working to make the best calls on behalf of the taxpaying public. So thanks all. Yield back.
Okay, before we bring the hearing to a close, I want to thank our witnesses again for testifying before us today. The record will remain open for 2 weeks for additional statements from the members and for any additional questions the committee may ask of the witnesses. The witnesses are now excused and the hearing is adjourned. Thank you.